Okay, we're going to go through properties of rectangles today. As you can see, I've got two blanks where we're going to fill in their properties. The first one I've already got filled in for you. I think we know that one of the properties of a rectangle is that it has four right angles. And you might be thinking that that's a property of a square, but really that's more of a property of a rectangle. It is true for a square, but it is a rectangle property. And we're going to talk about squares a little bit later. But for right now, all I need you to know is that that is the property of a rectangle, that they have four right angles. It's also got 5 bullet points up here of other properties of rectangles. Those are just the properties of parallelograms. And we actually went through 7 of those properties a couple pages back. You guys can go back and check those out if you don't remember what they are. But for all of the problems today, what you can think of is we're going to be using these two properties for the majority of it. But we can also use any of those 7 parallelogram properties from the previous page. I don't know what page it was, a couple pages back, and I don't have it on here right now, but there were 7 that we talked about. So if you don't have those, make sure you go back and get them from somebody else in the room. But for right now, we just got those 7 and then 4 right angles. The last one, and I think this is the most applicable to rectangles, especially if we go out and we want to be in architecture or construction or something like that. If I want to build like a deck, for example, and it's a rectangular deck, and I want to make sure that my corners are 90 degrees, the easiest way to do that, instead of taking out like a 90-degree angle checker or like a square, whatever you want to call it, you can. If this is my deck, this is a really bad one. I'm drawing on my computer here, so got to bear with me a little bit. If that's my rectangle and I want to figure out if it's really 90-degree angles, I can take my measuring tape and I can measure from this corner all the way to this corner and check its distance. And I can do the same thing over here. And if those two diagonals are congruent, that means it's a rectangle. So that's our second of our two properties, new properties for rectangles only, which would be diagonals congruent. Okay, so that's it. Diagonals are congruent. So now what we've got is now what we've got is two more properties. So that's a total of 9 properties, and all 9 of those properties would be possible to use in any of these problems that we're going through today. Sorry about that. I'm just trying to still get set up here. So number 1, if we look at that, it says the directions say that it is a rectangle. That's how we know that we can use any of those properties. So you got to make sure that it does say that it is a rectangle first. 1 second here. I'm still getting set up on my end. Instead of grabbing a calculator, I'm just going to pull up my key as we go through these. Okay, so number 1, I'm looking at what we've got, and we've got side length. So this has nothing to do with angles, so I'm not going to use that 4 right angles property at all in this problem. I'll have to use something with side lengths. And if I'm trying to find SQ, which is a side length, I take it back. I guess I will be having to use that these are right angles, because if I'm looking for SQ, what I've found is I've got these two sides, and then SQ is my third side, and it looks like if I know that this is a rectangle, then this would be a right triangle. So I could set up my Pythagorean theorem. The Pythagorean theorem would be 10 squared plus 24 squared equals c squared, where c is SQ. And then when I solve that, I think you guys can do that pretty quickly now you could have used the shortcut, I guess. But we should get x equals 26. And then if I have x equals 26, that's this guy right there. Now it's going to ask me a few more things. So QR, first of all, QR is going to be the same as PS. That's a parallelogram property, and a rectangle is a parallelogram property. That property is that opposite sides are congruent. So that would be 10. SR, which is this side, would be the same as the top, which is 24. And then SQ, we already found, we said that was 26. And then PR, PR is my other diagonal, and using a parallelogram property, we know that diagonals, using the rectangle property, we know that diagonals are congruent. My fault. Diagonals are congruent. So PR would also be 26. And then it wants QT, which is just a half of that diagonal. And we know that diagonals bisect each other due to our parallelogram properties. I probably should be marking those with different marks, but my diagonals are bisecting each other, which should mean QT is 13. That's a parallelogram property. Okay, number 2. I'm not going to go through all of these since I'm on video, so I'm going to go through, you know what, I'm going to actually skip down to number 3. I'll zoom in on it a little bit too. Number 3, we've got angles that we're dealing with now. If this is 27, we're going to know a few things. Now, this is actually kind of a trick that we didn't really talk about at the beginning of the video, but it is super important. When I have rectangles like this, and I know that my diagonals are congruent to each other, but also they bisect each other, congruent to each other from the rectangle property, but bisect each other from the parallelogram property, here's what happens. If they're congruent and they bisect, that means that this and this and this and this are all congruent on a rectangle. And that'll be true for every single rectangle because the rules apply for all of them. That if you bisect and they're the same length, those would be congruent. So therefore, I'm going to make this a little bit smaller so I can write. Therefore, what I've got here is an isosceles triangle. And I've actually got 4 isosceles triangles. I've just highlighted one of them. So if that's an isosceles triangle, it's got 2 sides that are the same. We also know that it's got 2 angles that are the same because it's an isosceles triangle. So this would be 27 over there as well. And then you could basically go ahead and figure everything else out about this triangle if you really wanted to. So like, what would this be here? This would be 63. This would be 63. This would be 27 because those are 90-degree angles, right? 27, 27, 63, 63. And then we've got the middle ones that we could figure out because they are triangles. So let's see, 180 minus 54 would be, what is it, 180 minus 54 would be, I'm blanking right now, 126, I think. Hopefully I'm right. You can check my math on that. A little early to be doing mental math, but that's, I think it's 126. So if those were both 126, you could use, or you could find the other ones as well. I don't even know what this question is asking for. So let's just continue with the question. So MJK, that is this entire angle. That's a 90-degree angle because it's a rectangle, so that's easy. MJL, I think we found that. MJL we said was 63. JLK is also 63. KML is 27. And then MNL we said was 126. I think that's all we need. We could find these by using the triangles though too, and I'll let you guys work on that. But that's it for number 4 or 3. This one, the toughest part about this is just fitting all the information on one picture. But it's really everything we've talked about so far will apply to that. So I just want to go to the next page and see if there's anything else that's new. So I guess on these bottom ones, we can go through some of these, but for the most part, these are going to be kind of simple questions, I think. We've got an angle at the top left here and an angle on the bottom right side. I know that those are alternate interior angles due to the fact that these lines are parallel, because if it's a rectangle, opposite sides are parallel because that's a parallelogram property. And if this is a diagonal, we've got alternate interior angles. If we've got AC as our diagonal. So if they're alternate interior angles, I know alternate interior angles are congruent. So I just go 11x minus 3 equals 7x plus 5. And I'm not going to solve that any further, but that's how you would set that one up. Number 11. I'll give you a second. the person in charge of the video can pause here, and I'll let you guys try to figure that one out. Go ahead and pause now. Okay, so I see that these two angles are pointing at the 90-degree angle. So they should add up to 90. So 3x plus 2 and 12x minus 17. If I combine those, that would be 15x and minus 15 equals 90. And then I'm not going to solve that any further, but you guys can go ahead and solve that from there. Moving on. Number 12. I know that it doesn't look like those come together to form a 90-degree angle, but they will, because this 5x minus 8 would be the same as this angle due to alternate interior angles. And so really what I can do here is just the 5x minus 8 plus the x plus 20. I guess I could have combined them. Let me do that quick. So what would it be? 6x plus 12 equals 90. If I combine those because of alternate interior angles. And then you guys can finish solving from there. But I will move on to this last one, number 13. And I want to pause for a second and see if you guys can try to figure out how to start this one, because this one is a little bit different than the previous one. So I'll let you pause, and then you can resume when it's time. Okay, so if you got it figured out, if this is 134, then we know that this is 46 right here. And like we talked about before, and this is the big key of this lesson, I think it would help a lot if we could understand this. These are all isosceles triangles due to it being a rectangle. So this and this are the same, but also this and this are the same. So if I'm setting up an equation, there's really two of these 5x plus 7s, which would make a total of 10x plus 14, plus the extra 46 degrees that we haven't talked about yet, should add up to equal 180. And then from there you can solve for x, and then I think that's it. Yeah, it just wants you to solve for x. So once you solve for x, you're good there as well. Okay, that's it. So that's rectangles. Just to recap quick, going back to the front page, any of the 7 parallelogram properties can be used. So don't just get caught with the 2 and then think that that's all you can use, because rectangles are parallelograms. So any of those 7 from the previous page. And then you've got these two with 4 right angles and diagonals are congruent that you also have at your disposal. For the rest of the class period today, you can work on homework number 4, which is basically the same as the problems we worked on together right now. That should be open online for you, so feel free to put that online as well. Okay, thank you.